Hi, I'm Jim W6LG, your ham radio Elmer. Welcome to my radio room here in Rockland, California. Been asked the question about connector loss again, and more specifically, what kind of connector should we use? And the answer is it depends. But let's take a look at three really common connectors that you're going to find on the back of a lot of equipment. And the first one has the name BNC, and it comes from Bayonet Neil Councilman. Now, there are two guys, one named Neil, the other Consulman, and so they created this bayonet connector called the Bayonet Neil Councilman connector. Can't say it. So that's a BNC connector. Good to probably a gigahertz or more, can handle a few hundred watts. Not the easiest thing to put together. This is a picture I took of one that I have in stock that has the pin and the crimp sleeve. A not so common connector that you might find on some really high frequency equipment. I say high frequency, I mean ultra high frequency equipment. Again, this is a picture I took of a couple of N connectors. N connector is named after Neil, its inventor. He did it in the 1940s, I think. So this is the N or Neil connector. And this particular one is a crimp connector. There's a sleeve for the shield on LMR 400. You can see the pin also has to be either crimped or soldered into place, in this case, soldered. The most common connector that we use is the UHF male. That's right, it's a UHF male. Why in the world is it called a UHF male? Well, at the time it was designed, it was really a banana plug with a barrel around it. So it's a banana plug connector, believe it or not. Invented in the 1930s. At that time, anything above 30 megahertz was considered ultra high frequency. It was very difficult to get things to work at that frequency. So that is the UHF male connector. That's its correct name, but it's also called a PL259 or PL259. And the mate, as you know, is an SO239, often confused because the numbers are somewhat similar. So what are the losses? I'm not going to measure the BNC. I'm going to do the higher power connectors. And so to that end, I'm going to use the RigExpert, which is a really neat device. By the way, the camera's here because I'm going to shoot some video with it that's of tiny SA. So this is the RigExpert 3000. So it goes to 3 gigahertz. There's a zillion things you could do with this. One of them is as a signal generator, and I may do that in the next video. In any case, I'm going to measure the losses in the Neil connector. Now this is 20. Now these are the UHF connectors. Sorry, this is 20 of the UHF connectors. How much loss is there? Is there much loss at 30 megahertz? You already know the answer to that. The answer is no. We've done that test several times. There really isn't much of any loss at 30 megahertz. The connectors that I meant to pick up are the Neil connectors, the N connectors. So it's a much better design. Maybe you can't handle quite as much power. I can't find ratings on a data sheet at curves for this thing. But how much loss is there in 20 of these? You're not likely going to have 20 in your station. But what's the loss maybe at 400 or 500 megahertz? If I can measure what's the loss at around 1 gigahertz. Same thing on the PL259, which is not such a fancy design. It was literally a banana plug with a barrel around it, and that was its origin. So it's not anywhere near as close to being 50 ohms, certainly not at 500 megahertz or 1 gigahertz. But are the losses on this much greater than the N connector? At 30 megahertz, I've already done those tests several times, and the answer is they basically have the same loss, which is 0. So let's take a look at this string of 20. So I've got 20 UHF, male, female. I've got 20 N connectors. What are the losses at 400 to 500 megahertz? And again, at 1 gigahertz, that's about as high as I'm going to be using on any equipment. So let's do that now, and I'll do it really quick, and I'm going to swap cameras and get that going right now. It's been about 4 days since the end of that last segment about coax connectors and what was going on around 400 megahertz. As I went up with the connectors to 1 gig, sometimes tested at 800, 900. During these 4 days, I did a lot of testing, and I got results all over the place. The connectors had various loss issues. Let me show you something. This I'll put the source for this in my comments, but this is part of the information that I got and another group got. So it shows in the blue, that's the UHF connector PL259 SO239 and the N connector. And as you can see, as you go through the various cycles, you can see what's going on with the loss. Now, this is insertion loss. This is about 1/4 of a dB. So that's pretty good, except, and I'll get to that in just a minute, here's the PL259, the UHF connector, and you can see it really is all over the place, but the trend, generally speaking, as you might expect, is significant losses. So, for example, at this particular frequency, which I think was 855 megahertz, the loss on the connectors that I was testing showed about the same, about 1.5 dB per connector, which is astronomical and not something that I don't think any of us would be happy with, that kind of number. So the results I got were all over the place on the N connector, and it turned out that there were different qualities of connectors. Some were silver plated, some were not. Some had what looked like a plastic insulator on the inside. Others looked like it was Teflon. The conclusion I came to after like 4 days of trying to figure out what's going on here, what's with this picture, and I did continue various combinations of connectors. This is N connectors. To see if I could draw a conclusion. I did draw conclusions, but it may be not quite what you would expect. Name brand N connectors are fine and predictable, and you can put them on the end of a piece of coax if you know how to do it, and get the same result pretty much every time. The Chinese connectors, the import connectors that could be silver plated but are generally nickel plated, some of them have what looks like a pink insulator around the pin. Those, they're all over. 1/4 dB loss, 1.5 dB loss. It was frustrating because in the chain of connectors, there might be a couple from China, or maybe 3 from China out of the 20 connectors I started off with. So I had to figure out what to do. And in the beginning of the video, I said BNC, N connector, and UHF connector. Which one do you use? And I said it depends. It does depend. Here's my advice. If you need a connector that has very low loss and you're going to be above, let's say, 2 meters, use only a name brand good quality connector that states its loss at various frequencies. Also understand that that connector may not be able to handle legal limit. Also, that the pin has to be absolutely perfect in the male connector. So when it's screwed onto the female, the two mate together with no issues. If the mating of those two connectors ends up not being perfect, or maybe maneuvering a pin a little bit, there's going to be a carbon or a resistance that builds up. And over time, that particular cable will not be usable just because of the end connector. Used end connectors, if they've been attached to a piece of coax, no way. If you're at a swap meet and there are name says right on it, whatever that brand is, Amphenol or something, if you can look at that connector and see that it's in a bag that hasn't been opened and it says Amphenol, that's probably okay to buy. But otherwise, stay away from them. They're just crazy results. Sometimes the loss on that connector was equal to the loss on a UHF male, which is just crazy bad. BNC connector, great to several gigahertz, good for a couple of 100 watts. Really, really low power stuff, it's fine. For example, it's used in the drive side, the input side of some of the Henry amplifiers. UHF male, frankly, a really good connector. It's maligned a lot, but when I tested it, they're not so bad. If you get one that's silver plated, that has a Teflon insulation and a gold pin, and you can crimp the back end of it and solder the pin, the center conductor, into the pin of the connector. That will be a beautiful connector. Will work well to 2 meters and even 400 megahertz. Beyond that, it does get a bit weird, but it's a fine connector. I don't know where the BS comes from. Some guy was saying on a YouTube channel that some guy out of Florida or something, that there was a dB loss per connector was about 1 dB. No, it's not. It's nothing. At HF, it's zero. Yes, there's an insertion loss, but we can't measure it with the equipment that we generally have. Should you go to end connectors? Probably not. They're not good for power, and they have to be just perfect in the way that they're installed. A PL259 is pretty forgiving. You can make some mistakes in its assembly, and it will come out to work okay and be close to 50 ohms. That's my rambling. I'm disappointed because I thought I could put up a chart that would say, okay, the end connector at this frequency, let me put this back up on the screen, has so much loss. But I can't. For example, look here at 6, now I got this same data at around 600 megahertz. It's down here. That's the end connector then is really down here. But to hit this spot, you have to be really careful. You're not probably going to make this one, or this one. And I don't know where it goes from here. And frankly, I don't know that I care. Okay, so that's the upshot. PL259 SO239 are great at HF. BNC connectors are good for really high gigahertz, but you got to know how to put it on. Same thing with the end connector. It can handle much higher power, but it tends to get a bit weird at a few 100 watts as you get to 800, 900 megahertz. All right, that's my story, and I'm sticking to it. It's been a frustrating 4 days because I've tried all kinds of things. The RigExpert worked great. It gives me lots of data. It's the connectors I was working with, and one would have a loss up here, another one lost down here, and then I'd swap them around, and it just, or I'd have 3 in a row that were good and then one that was bad. It means testing each individual connector in my radio room, and I'll do that in the next couple of days when I have the energy back to do it. I am Jim, W6LG, your YouTube Elmer here in Rockland, California. Thanks for watching this. And if you have any comments, post them below. If you have any questions, post those below. Probably some of you have done the kind of testing that I was trying to do, and you might want to give me your comments on that too. All right, 73. See you later.